Hi, so I just want to make a short video here explaining a looping. So I have this general scenario going on with an arithmetic sequence. So I want to walk through with you what some of the symbols mean mathematically, and then I want to explain where that is in the simple coding that I made on the left. Right. So my example is looking at an arithmetic sequence, which is a sequence where you're adding a certain number every time, right? So, for example, an arithmetic sequence, an example might be 1, 3, 5, 7, 9, 11, 13, so forth, right? So notice that I'm adding 2 every time here, right? So if you're adding a specific number every time, if that's your rule in your sequence, that's an arithmetic sequence. So, and also an easy way to think about it is if you graph an arithmetic sequence, if you let n be your input and a sub n be your output, that will be linear, right? So you can think of it like in this form, y equals mx plus b, right? So you can think of this as a plus 0 here. So it matches up where a sub n is your output, the n variable is your input variable, your x, 2 is your slope, and then in this case we're going through the crossing through the origin, right? So I just made this quick table here to walk through. So if I want to know what the first term is in a sub n, right, I plug 1 in for n and I would get just 2, right, because we would take 2 times 1. Then here to get the second term, I would take 2 times n, which is 4, right? Then the third term would be 6, right? So we're just taking each and doubling, right? So, or in other words, we're adding 2 every time also, right? That's our rule for the sequence. So this would be 12, 14, 16, 18, and lastly 20, right? So then an easy way to think about a series is essentially adding up all these terms in a sequence, right? So here, so if you look here, I just wrote some sigma notation where we have n equals 1, so that's like our starting value, right? So this is like our starting value, starting input, and then here, this is where we stop, right? And then over here, this is kind of like our rule, right? So this 2n is our rule for what we're doing, right? So let me make some room here, get rid of this. Right, so when we see sigma n equals 1 to infinity, 2n, right, this means put 1 in for n, so you'd have 2 times 1, right? And then the sigma notation means that we add all these terms together, right? So then I'd have plus, and then what's the next n value, right? The next integer, that would be 2, right? So then I put 2 in, and then I would have plus, and then 2 times 3, right? And this would just keep going on indefinitely, right? That's why we have stopping at infinity, right? So this would keep going, this pattern on forever. And notice each of these guys are terms above, right? So literally we're just adding the terms up, right? And so forth, right? So now I'd like to connect that over here with the coding. So I have a simple coding activity. So let me go ahead and just push play so you can see what the, and look over here in the preview to see what's going on. So I have this going at just 1 frame per second, so it goes slow so we can look at this. But here's the current sum, and then here's how many terms I have, right? So after 10 terms, you should have a sum of 110, right? Hopefully you saw that, and it just keeps going, right? So let me go ahead and stop the code here for a moment, and then let's dissect this code, right? So I'm just going to take a quick clip of this. And paste this in here, right? So then I can write write on it. So I'm going to write, red would probably be a good color, right? So this part here, this is defining a variable, right? So I'm saying let a underscore n, let this equal 0, right? So in other words, kind of like a starting value. I'm saying initially let a sub n equals 0. Same thing here, right? With this n equals 1, I'm initially letting n equal 1, right? And this frame rate, you should have seen a little bit before. This is going to control the speed of this function, right? So just like in the pi example, right? So I actually kept a lot of the code from the arctan series example that you looked at, the infinite loop. That way it looks similar to you. So then this part in the code is essentially putting the title on, right? So if I hit play, notice it says loop example at the top. That's what this is generating. And then these numbers after are going to control where on the screen it shows up, right? So for example, if I change this number to, I don't know, 25, right? And if I hit play now, you notice it skipped over to the right a little bit, right? So let me add a little more to make it a little more drastic. So if I hit plus again, notice it shifted over even more, right? So that's going to control moving it left and right, and then this next number actually controls moving it up and down, right? So I want to put this back at 10, how it was, right? So then now let's really quick look at this guy. So one thing to note, so just a quick example, if I have x plus equals 10, what this means in coding is x equals x plus 10, right? So that's what this guy means. It means take your x variable and then plus 10, right? It's going to make sense why we have that set up this way in a moment, right? So this a sub n plus equals 2 times n, right? And notice I didn't write just 2n. When you code, we have to actually use the operator times, right? The asterisk for times. So it's going to take the previous 2n and then add the next 2n to it, right? So if we keep going, let's see, this print option here, that just is going to add the code down here below the code. That generates it there. And then this next one, the draw text, this adds the words and the numbers over here, right? Same with this guy, right? So that's what these control, right? And then lastly, this is what controls the loop, right? Is this, right? This means n equals n plus 1, right? So what's happening is originally a sub n starts at 0 and n starts at 1, right? So let's go through a couple iterations together. All right, so maybe I'll pull this over a little bit for right now. Right? So let's say the first iteration, right? The first iteration, a sub n equals 0 and n equals 1, right? So that's what's controlled. And then as our computer program runs down the code, it says, wait a minute, we have this variable, which is a sub n, right? Or a underscore n equals a underscore n plus 2n, right? So that's what I have it set up originally. So what's going to happen is it takes this value up here, right? Puts it in for this, and then takes n equals 1 and puts it in for this. So it gets a underscore n equals 0 plus 2 times 1, which is what, 2, right? So the first term is 2, right? And then once it hits this line of code, right? Once it hits this line of code, it says, hey, now redefine n to be n plus 1, right? So let's look at the second iteration now. Right? So this redefines n to be our previous n, which is 1 plus 1. Right? So this was our previous n, which is 2. Right? So notice up here, our first iteration is n equals 1, and now the second iteration, n is going to be equal to 2 now. Right? And these numbers don't always have to match, right? It's just this is just a basic example where it works out that way. So now when it goes to the a sub n, right? The a sub n value is already stored to be 2, right? So now when we get to a underscore n, it's going to take the previous value, which is 2, and then add in 2 times our n value, which is 2. Right? So this would equal what, 6 then? Right? So then now when you go to a third iteration, so let me do one more. Right? So it's important that to store these values, right? So right now the computer stored a sub n to equal 6, right? And right now n is 2, right? So these are stored initially, right? So right now n is 2, and then a underscore n is stored as 6. So then when we run this line of code, right? When we run this line of code, now we're going to get n equals n plus 1, right? Once you get to this line here, which is going to give you 2 plus 1, which is 3, right? So right now, n is stored as 3. Right? So then it goes back up to the top, and then once you get to the a underscore n, we're going to take our previous a sub n and then add 2n to it, right? So our previous a sub n was 6, so this would be 6 plus 2 times 3, which is 6 plus 6, which is 12, right? So now that's the new a underscore n, which is 12, right? And it keeps doing this, keeps cycling through this, just like it would when we did it by hand, right, up here, right? So you can see those values being stored, right? Because 2 plus 4 is 6, right, which is what we had here, right, for this iteration. And then the third, if we add the first 3 terms together, we get 12, right? Which again, if we scroll down, that's what we got here last, right? So we keep generating the sum as we go, right? And since this doesn't have like a stopping value, right, this will just keep going, right? So if we put your attention back to the code, so let me click stop and then push play to rerun, then you can see this in action, right? And actually, let me slow this down even more. Right? And we'll talk through this. So the current sum is 2, and then so 2 terms we get 6, 3 terms we get 12 like we did, right? And so it just keeps adding more and more of those variables to it, right? So the computer starts at the top, goes through the code, And then once it hits here, it starts back up here, right? It keeps going down and so forth, right? It keeps doing this loop back and forth, back and forth, back and forth, all right? So hopefully this helps you understand looping and will help you with this challenge question. Thanks.